we need to progress as a society, and we need to improve healthcare for us, for our families, for everyone around us.
Yeah, I could see the impact, and I thought, this is an opportunity to head in this direction where I can take playing with some really cool physics, but have it actually become something that changes somebody's life, hopefully someday.
Welcome to Beyond Research. I'm your host, Stephanie Reed. There are many challenges impacting a healthier population here in Nova Scotia. Physician recruitment, access to primary care, an aging population, infrastructure, equipment, and facilities renewal, and increased costs for healthcare research and delivery. In this episode, we have a fabulous conversation with Drs. Stephen Beyea and Adela Cora on their research in local emergency departments to help address some of these challenges. This type of project really gives you an inside look at how that research can provide benefits to end users in real time. Sometimes we may think research has no impact on my life, but our guests today shine a light on just how much of an impact research has on our daily lives as Nova Scotians.
I basically grew up literally hanging around medical imaging. So my father was head of nuclear medicine at a hospital in New Brunswick. When he was on call as a little kid, I hung around. It was the 70s. And so
just a normal childhood.
Exactly.
This is Dr. Stephen Beyea from the IWK Health Centre in Halifax, Nova Scotia. He is leveraging his medical imaging research program to improve MRI accessibility and diagnostics in an emergency setting. By facilitating access to novel medical technology, his work has not only led to the installation of cutting-edge technologies in local hospitals, they're poised to improve diagnostics, reduce wait times, and in some cases, eliminate the need for secondary surgeries.
A key part of what we do is that we are sort of foundationally interested in not just creating cutting-edge technologies, but also working with industry partners and clinical partners to figure out how a new technology is not just better technology, is it better healthcare? And if it's better healthcare, how do we get that out into the world via partnering with industry, and in particular with Canadian industries and Nova Scotian industries that then allow us to take the research that we're doing and get out into the world.
Dr. Beyea's research has attracted millions of dollars in investment by multinational enterprises such as Electa Neuroscience and GE Healthcare, and driven validation of novel medical technologies from small and medium enterprises like Synaptive Medical.
In science, research papers are the currency by which we communicate what we do, but research papers don't treat patients. And so the only way we can actually have the impact that we have is if we figure out how not only to turn this into a research paper, but how to turn it into something that can actually impact healthcare. And we do that by partnering with healthcare providers like Dr. Cora and the outstanding work that they do, as well as with industry partners such as Synaptive Medical, as an example. They were the ones that led the concept and engineering design of this. It's an MRI, but not exactly the same as the typical MRI that you'd be used to seeing. It's one that is engineered from the ground up to be optimal for things like neuroimaging, and in particular, applications like rapid screening that might be needed in urgent care situations. It's a very different type of MRI than that which we're usually using in diagnostic imaging. We have a healthcare system that needs innovation. We need new technologies to help us innovate. Industry has innovations, but to test them, you can't develop a medical technology outside of the medical environment, and they need partners within healthcare. And the other piece of that then is academia and those new discoveries that then feed into what are those ideas that would allow us to do things like image faster, as an example. And so in all these projects, we have graduate students and postdocs and undergraduate medical students and so on who are involved in this from an academic perspective, driving new discovery, partnering with healthcare that then allows us to evaluate this in the healthcare setting, partnering with industry who can bring new innovations to the table that they need validated in healthcare. It's a three-legged stool and we need all three legs.
We're also joined today by Dr. Adela Cora. Dr. Cora is an undergraduate medical education program director for Diagnostic Radiology and an active practicing physician in the Neuroradiology section of the QEII Health Sciences Center in Halifax, Nova Scotia.
Basically, in my day-to-day job in the hospital, I basically diagnose X-rays, MRIs, CT scans for people that have diseases of the brain and spine mainly. And then I also do research on kind of similar topics. Stroke is one of the things that I kind of like to do research on, especially. And then also I am the undergraduate medical lead for radiology. So I'm also part of Dalhousie University, and I teach there as well.
So you have nothing going on at all. You must be incredibly busy. So for people listening who may not understand what an MRI is at its core, can you just break that down?
Really, at its heart, MRI, magnetic resonance imaging, involves a strong magnetic field and the use of radio waves. And through really, frankly, some funky quantum mechanics, there's a whole bunch of physics that's happening in the background, which is the stuff that gets physicists like me excited. But really, just using this combination of a magnetic field and a radio wave, we're able to create pictures of what the inside of the body looks like. And in particular, the thing that makes MRI so powerful is it lets us take pictures in which we can tell the difference between different types of tissues in the body, and more to the point, between healthy and not healthy tissue in the body. Ultimately, then, MRI is, from a diagnostic imaging perspective, one of the best tools that we have for doing clinical diagnosis of the soft tissues within the body. If you watch shows on television of Grey's Anatomy or whatever, often then it's a patient sliding into a long tube, and you hear various bangs and so on, and that's the sound of an MRI working. In this case, the MRI is a bit different. It is very small. It's maybe 3 feet by 4 feet. It's very light. So the normal MRIs get picked up by cranes to be delivered to hospitals. This one came in on a little hand truck. And it also has a far weaker magnetic field. I would know it's not mobile, but it is small footprint, lightweight, and for various technological reasons, much easier to place in different environments within the hospital compared to a traditional MRI.
Right. So you wouldn't have to build like a new add-on or addition to an existing. Right.
Many MRIs, the traditional ones, literally weigh 12 tons and need to sit in a really large room with reinforced flooring and so on and so on and so on.
Right.
So all of that then fed into the engineering design reasons why Synaptive Medical did what they did.
So Dr. Cora, you've been working with Dr. Beyea since 2019 on a variety of research projects. This particular one is taking place in the emergency department. Can you explain what that looks like for patients walking through the door?
Let's talk about stroke, for example. And so stroke is important because it is the leading cause of patients being dependent on others after having a stroke. So being able to treat them quickly is really important. And one of the treatments that has been developed since about 2015 is an interventional treatment where we can go through the arteries to the brain. And if there's a clot there that blocks the artery and blocks the blood flow to the brain, remove that clot. So as part of that, everything needs to be done very fast. And so it's really important to get to the diagnosis to know that, there is a clot there, for example, really quickly. And so currently we use CT. And so if someone has a large stroke, typically CT would pick that up generally. But if someone has a smaller stroke and the clinical signs and symptoms are not so clear cut, I think it's especially at that point that having the MRI scan done and then saying, oh, yes, look, there is a stroke here, and now we're going to start treatment right away, rather than kind of waiting a little bit and saying, okay, we think it's a stroke. Obviously, all treatments have, potential side effects and complications, and there's contraindications. So really, the clinicians want to know, what is the diagnosis before embarking on a treatment.
So, Dr. Beyea, this research project centers around that partnership with Synaptive Medical. Can you tell us a little bit about how that partnership came to be, how that started, and how you were successful in bringing this technology to Nova Scotia?
It started with myself and Dr. David Clark, who's the chief of neurosurgery at NSH, getting on a plane and flying to Toronto, walking into their boardroom and saying to the president of the company, "We want to be your first adopter. We think that Halifax and Nova Scotia is the place where you should put the very first MRI of this type that you've ever made, because we want to be the innovators and early adopters who bring this into the healthcare center." And so that's where that started. And moving forward through the tremendous support of various organizations, but in particular Research Nova Scotia, that then led to us having here in Halifax the very first of these MRIs in the world.
So, Dr. Cora, this technology right now is part of a bigger research program. But if this technology is implemented in the department long term, what kind of impact does that have on capacity of not only the emergency department, but also the health system?
In terms of the clinical kind of utility of this, it's really amazing, because with the amount of patients we have in a hospital and patients that come for scans every day, I think it would be really easy to fill this scanner to run for a full day. And so what would happen is that then we would have space on the other scanners, the 1.5 and the 3 Tesla scanners. And so patients that need that scanner more, or we would be able to scan them there. And also, so that means overall we'd increase our throughput by a third, basically, because we would have one additional scanner. So that is powerful.
If the research shows what we think it's going to show, how easy will it be for health centers to adopt this technology in their emergency departments?
The cost of this MRI, because it is smaller, everything is not as expensive in terms of the machine itself, but also running it on a day-to-day basis. For example, if we have a patient that comes into the hospital, they will typically be first investigated with a CT scan. And then if that doesn't give us the answer and they still need to be in hospital, then a few days maybe down the line, they will have an MRI. So in terms of this scanner, because it's so kind of light, portable in a way, could be placed right next to the emergency department, potentially patients could skip a step and kind of go straight from the emergency department to this scanner, and then have this scanner and have a diagnosis that is in a shorter time period. And so what that means is, one, that they could potentially start treatment faster, but also in terms of the financial gain of that, if we have a patient that can be diagnosed and start treatment right away and then go home, well, then maybe you don't have a patient that needs to stay in hospital for a few days. So that is a huge financial advantage.
So, Dr. Beyea, this MRI is small, but the value is big, even though it may not be the same level of picture that the traditional MRI would show. Can you talk about that value, especially in the emergency room setting?
I think to take stroke as an example, so Dr. Cora alluded to this idea of creating these really rapid screening exams. And so this idea of a very different use case for MRI, in which, in that example, all we really need to know in that moment is there a stroke, yes or no? If the answer is no, we don't in that moment necessarily need to know what else it might be. If it's a stroke, we need to know that right away. If it's something else, then that can be dealt with in a less costly, less urgent way down the road. But every patient that we don't have to send for a traditional, most brain exams are about 20 minutes long. Every time we can keep a patient from occupying one of those slots is an opportunity for us to decrease the wait time list that we have, because now we are freeing up slots to do these other things. There's a part of all of this in terms of the flavor of where research is going, is the recognition that we need to pay attention to the role of value. And so sometimes we absolutely need, the really, just to use MRI as the example, the really high magnetic field, expensive technology. Sometimes that is absolutely needed, but not always. And sometimes then the role that instruments like this can play is if it can answer the question, but do so in a way that is either faster or less expensive and so on, and reach the exact same answer, then that's better value to our healthcare system. And I think in the context of healthcare in 2023, that increasingly there's this recognition that that's a piece of it. It can't just be better technology. It also has to be potentially better value to our healthcare system.
So, Dr. Beyea, how many research projects are leveraging this new MRI technology? And how are these projects continuing to evolve and add value for patients and caregivers?
I forget the exact number, but it grows every week. I literally 2 weeks ago had a meeting with Dr. Sam Campbell in the emergency department, and we're out of that developing another brand new project in which we'll be recruiting from the emergency department. The list is growing all the time. Yeah. I think as well, one of the things is that we have been able to evaluate along the way as we do these projects like the work that Dr. Cora is doing in stroke and so on, is we're now collecting these large pools of data. And that allows us, as we build up the pools of data, to bring in artificial intelligence. So the role that deep learning and AI can play in helping us make these images even better. Because one of the things is, as Dr. Cora alluded to, is that usually CT is seen as fast, MR is seen as slow, but CT is seen as maybe not sensitive to things in soft tissues like the brain versus MRI is. But there's always trade-offs. So we're doing a lot of work in saying, well, how about we give up some of that image quality and but make it faster? So can we trade off some speed for some quality? And if it's my mom who is in that emergency department and needs to get imaging, I'm not going to give anybody artistic merit points additionally for the image was pretty. It doesn't matter if it was pretty. Was it good enough to reach the diagnosis? And so we're looking at, can we make the MR images that we're getting with the scanner even faster to provide even better value in this sort of a setting? And part of the way we do that is by bringing in things like artificial intelligence. And so there's lots of these different almost sideshoot projects that are coming off as well. And can we take this and, how about now we reconstruct the images using AI and so on? And it just keeps growing and growing.
Wow. It's incredible. I feel like there's a million stories of how you're leveraging this technology right now. And if you continue to see these positive results, do you see this becoming a new standard of care in an emergency room setting and or even outside of an emergency department?
So I think, yes, I think it has great potential. One of the main benefits of this is that it's a smaller machine, easier to place next to the emergency department. Patients can kind of go there right away from the emergency department. And I think from what I'm seeing up to now, I think that this is going to be one of the next steps with stroke. For example, once we finish this project, we're going to try and see if we can get patients to go straight away through the MRI machine and maybe not having the CT scan, for example. The other thing I want to mention is that one of the strengths of this machine, because the more you go like a higher magnetic field, you can get more artifacts from things like implants. And so one of the things that we're talking about, and that's kind of still in development, is whether we can assess implants that patients have in the brain with this machine better. So for example, because I do procedures as well, and sometimes some patients have certain diseases that need to have stents placed in the brain, similar like the heart, for example. And so those stents, once they're placed, it's really difficult to kind of image them. We get artifacts with CT and with MRI. And so typically what's needed is for them to have another procedure where we go from the groin and we kind of do a cerebral angiogram. That's what that test is called. And then we can assess the stent and how it's healing. And so with this machine, I think there is the potential for us to be able to visualize those kind of stents better and see how the blood flows and whether it's all kind of healed nicely, and it's kind of management in terms of what medications these patients need. But so if we're able to save a procedure for a patient, then again, that is a big thing.
I can tell by how happy your faces are, how exciting it is.
There are now hospitals in Canada that are now buying this and adopting it, but we were the first adopter. We were the leaders in this particular field. And I think it's a great success story for Nova Scotia that it wasn't Toronto, Montreal, or Vancouver that led this, and we follow. We have led, along with this Canadian company, the clinical implementation and testing of this technology.
I'm looking forward to being able to use this on a clinical kind of setting on a day-to-day basis, because I think it has lots of advantages. All this development, all this research, and I think we need to move from that to the clinical side and be able to use this on a day-to-day basis and benefit our population here in Nova Scotia.
Technologies like this are coming, and we can either wait until Boston, New York, or whatever develops it, and then someday down the road, when other people's patients have already benefited, we can pay full price. Or we can be the leaders and say, we want to plant our flag here in Nova Scotia and say, we are innovators here and we can play a role as the early adopter. So my hope is that this becomes not a single example, but that we could fill up podcasts with group after group coming in and having these same sorts of stories about the ways in which we can innovate healthcare by marrying academia and healthcare in industry partnership.
Research matters because it's what drives us forward. We don't want to be followers. We want to be leaders, and we want to improve healthcare. And it's a lot of work, but it's worth it.
As you heard, Doctors Beyea and Cora are passionate in their desire to positively impact those around them. They are helping to create an environment that is conducive to the creation of the next generation of researchers, clinicians, and entrepreneurs who understand the complexities of working in our healthcare system. In Dr. Beyea's lab, this has resulted in students eager to contribute to both healthcare and economic development. Most importantly, he is demonstrating how strong partnerships in healthcare research can improve patient care sooner. We hope you enjoyed today's episode. Be sure to hit the subscribe button and leave us 5 stars. You can also follow us on Instagram at Beyond Research Podcast and let us know what research topics you would like to hear on the podcast. Thank you for listening, and we'll see you next time.